This is question 4. I'm gonna start by underlying the key terms and hopefully explaining them. So we'll start with 5.65 grams. So this is a mass quantity. Grams is a unit for mass. A pure magnesium carbonate. Well, pure means you don't have impurities, so you can assume that all this 5.65 gram is magnesium carbonate. The formula for magnesium carbonate is MgCO3. Well, they give you here, but anyway, you should know this, I think. It is reacted with excess. We see the word excess and we sweat and run and cry. Try not to, just keep reading, see what happens. It's reacted with excess dilute hydrochloric. I have to have the word acid here, so dilute hydrochloric acid. This is why I'm doing these solutions, so I can actually proofread at the same time. Now, the reason why the word excess is there is telling you that the amount of product is going to depend on the amount of magnesium carbonate, because if hydrochloric acid is in excess, magnesium carbonate by default is going to be the limiting reagent. So please don't freak out because you see excess reagent. And the limiting reagent is going to control the amount of product. So if you want to work out the number of mole of any of the products of the reaction, you need to use mole ratio and you need to use the number of mole of magnesium carbonate. Okay, what is the question asking for? What is the volume of dry carbon dioxide gas? So volume is being asked. This is a gas. Now, if something is a gas, immediately think universal gas law, PV equal to nRT. You are allowed to use this formula. You are allowed to assume that every gas is ideal. So this is the ideal gas equation. In high school anyway, if you're continuing with chemistry later on, you're going to see the real gas laws, which is a lot more interesting. Okay, what is the volume of carbon dioxide gas produced at 101 kilopascal? So you are given pressure, excuse me, and temperature of 25 Celsius degree. Okay, you're given a chemical equation for the reaction as well, so that's another thing to keep in mind. Now I would say that is all the important key terms that I have identified. And I'm just going to go ahead and summarize the question once more, just to make sure we are aware of what is given and what is required. We are given, first of all, the mass of magnesium carbonate, which is 5.65 grams. We are then told that magnesium carbonate is the limiting reagent, which means if you want to find any product, well, I have very kindly provided you with the equation. Hopefully it's balanced, which is not balanced, so let's go with the 2 here. Ha ha ha, that is embarrassing. Okay, then you can use mole ratio. So you actually, from that equation, also know that the number of mole of magnesium carbonate is going to determine the number of mole of carbon dioxide, which is the unknown here. So this is a 1-to-1 mole ratio, because there's one here, and then there's one here, which is another way of saying that they have the same number of mole. CO3 equals to the number of mole of CO2, which is another piece of information that's given to you because they tell you that hydrochloric acid is in excess. Okay, what else? Yes, you're given the pressure of that the carbon dioxide is being collected under. So the pressure here is 101.3 kilopascal, and the temperature is 25 Celsius degree. I think I'm going to go down a little bit actually, and I'm going to write it down here so I have more room for the calculation. You are required to find the volume of carbon dioxide, which is a gas, which means that you can use the universal gas law if you want to. All right, so how are we going to go from what is given to us to the unknown? I think the universal gas law is going to be key here. I know that if PV equal to nRT, I can find volume as, I think this is, okay, volume is going to be nRT divided by pressure. So number of mole, this is the universal gas constant, which is 8.31. Temperature is already given to you, even though it's not in the correct unit yet. And once again, this is a very important thing to remember when you use a universal gas equation, is that you need to make sure all the physical quantities are given in the correct unit. Kilopascal for pressure, liter for volume, and Kelvin for temperature. So my temperature is now in Celsius degrees. I'm going to convert that to Kelvin by adding 273. Pressure is already in kilopascal, so that's good. And the volume, whatever my answer here is going to be in liter, given that the number of moles actually in mole, not millimole, megamoles, anything like that. Okay, so we already have temperature, we already have pressure. The question is, we don't have the number of mole of carbon dioxide. However, we're given the mass of magnesium carbonate, and because of the equation, which I have balanced, and the fact that magnesium carbonate is a limiting reagent, you can use the mole ratio here. So I think I am going to start by finding number of mole of magnesium carbonate using the mass of magnesium carbonate over the molar mass of magnesium carbonate. So you have to use magnesium carbonate 100% here. You cannot use the molar mass of one thing over the mass of another thing and expect to get a correct answer for the number of mole. And once I've got the number of mole of magnesium carbonate, I can then determine the number of mole of CO2, which is just the same as the number of mole of magnesium carbonate. And once I have the number of mole of carbon dioxide, I can plug that into this equation with the pressure of carbon dioxide and the temperature of carbon dioxide, and that will give me the volume. All right, that's my plan. I'm just going to put stuff in here. You're going to need a periodic table so you can actually determine the molar mass of magnesium carbonate, which I guess if you want you can put as an extra step, but I'm just going to do all of that here. So magnesium is 24.3, looking at 12 for carbon and 48 for 3 oxygen. So the number of mole is 0.067 mole. This is a 1-to-1 mole ratio, so 0.067 is also the number of mole of carbon dioxide. And now I'm just going to put my number in. 8.31, temperature is 298, and pressure is 101.3. Okay. Divided by, I got 1.64. And since I've just used the universal gas law, the volume has to be in liter. Alright, B is the answer. And I need to go back and check, well, do some editing, I think. But that's it.